Hello everyone, myself Ramajan and my teammates are Vishal, Timothy Persona and Sam Saran. Our project title is AI-based system for detecting fake image refund claims in instant delivery apps. And this project presents a web-based system for a real-time fake image detection. The framework that we have used to train our hybrid model is TensorFlow. And this system is basically this system is designed for low latency performance with multiple user support. And the problem statement is nowadays many of the quick commerce platforms or instant delivery apps are facing issues in their refund and complaint verification. So with the rise of the AI, the customers are using the ChatGPT or any other chatbot to create images that can appear genuine. So these fake images are difficult to detect through manual inspection, and the existing systems are lack this intelligence. So to address this issue, we have created a system that can easily detect whether the image is a fake, whether the image is fake or AI generated, or it is a real one. The main objective of this project is to build a web-based system that can detect fake or manipulated images using an hybrid deep learning model. And the data set we have used is SciFake, which is taken from Kaggle. So it consists of 1,20,000 images, and the sample images are listed below. So we can see it. The dataset properties, and so there are 1 lakh training images and 20,000 testing images. So totally there is a 1,20,000 images. uh, for the real category consists of 60,000, and the fake it consists of 60,000. The image size is 32 cross 32, and the mode is RGB format, which means red, green and blue. And this is the overall project flow. First, the user will feed the image as an input in the localhost, and the image will be sent to the deep learning model, which is at the back end. So it will process the image, and the image will be simultaneously sent to both CNN and VAT. The fusion is how the result of CNN and VAT is concatenated to provide the output, which is a real or it is a fake. And based on the output, the real or fake will be shown at the front end. This is the CNN branch. Basically, it is a CNN plus VAT, which is a hybrid model. So here I'm explaining the CNN branch alone. The input should be 32 plus 32 into 3, which the 32 plus 32 means it is a image size, and 3 is the RGB format. So the convolution layer consists of two convolutional layer. Um, so one convolution layer followed by the batch normalization, and another convolution layer followed by batch normalization. At the end, we can have a global average pooling, which converts the future maps into a dimensional vector. So this is the vision transformer part. Same, the input image is 32 cross 32, and the first the image will be processed in patch extraction, and then followed by the positional encoding. And we can have a transformer encoder which consists of four transformer layers. Each layer consists of multi-edge self-attention, residual connection, multi-layer perceptron block. The multi-edge self-attention is used to learn the differences between all the patches, and the residual connection is used to add the input to all the residual output. So it will provide an output as a local feature vector. Basically, a vision transformer is used for the global context. This is the hybrid feature fusion. So the output of CNN and VAT will be concatenated to provide the output. So at the output, we have used a sigma activation function, because it is basically based for binary classification. So whether the image is a real or fake. And the working of the project is, the first the user will upload the image, and the image will be pre-processed, and it will be sent. It will be sent to both CNN and VAT. And CNN is responsible for the local feature extraction, and VAT is responsible for global understanding. So combining both to provide the original output, and the output will be displayed on the front end. So this is the pre-processing module. The input image will be fed, and it will be resized. The normalizing is normally the images will be have a 0 to 255 as a pixel value. So if we normalize it, it will be resized to 0 to 1, and data augmentation is like rotation, zoom, flip, all those things. And we need to create a batch size. uh, and then and the pre-processed image will be sent to CNN and VAT. So as I said earlier, this is the block diagram of the CNN branch, and this is the block diagram of vision transformer, and this is the fusion working. So the output from CNN branch and VAT branch will be concatenated, and using a dense layer and also droplet, we can have a single output at the single. We can have the single output at output. So training and this is the training and testing loss graph. So although we can see some spike, the model has learned the model has achieved a very good accuracy. This is the training and testing accuracy. So this confusion matrix depicts that the model is not overfitted, so it is more generalized. This is the performance metrics of the hybrid model where our model achieved accuracy of 0.90, I mean 93%. So this is the web interface. This is the output of our project. So we have hosted and local host, and this is the reference we have used for our project. And this is the paper acceptance that we have got the acceptance for our project. So this is the training notebook of our hybrid deep learning model, which is CNN plus VAT. And here we can have the importing of data set from Kaggle and followed by importing all the library function and the TensorFlow as a frame. And this code is responsible for the image augmentation and image preprocessing. We can have the training and testing images, which is and their location is mentioned here. And this part is responsible for creating the training batches and testing batches. We can have 391 training batches and 79 testing batches, and the fake images are represented as 0 and the real images are represented as 1. And here we can have the multi-layer perceptor and block having the dropout rate is equal to 0.1, and the patch extractor and the patch encoder layer. And this cell is responsible for the creating of CNN plus VAT, which is a hybrid model. Uh, and, and then here we can have all the summary, like the how many dropout layers and how many dense layers, and what are the parameters that we are using in the training notebook is mentioned here. And here we can have the optimizer as a cosine decay, and another optimizer as add W. And the last function we are using is binary cross entropy. Initially, we set the epoch for 25, but the training process operated to so the because for the training level until the accuracy remains the same. So we didn't continue for all the 25 epoch. So we have loss and accuracy curve. Although the model have spikes in between, but the model learned well and better. So it is the confusion matrix. So it shows the model is not overfitted. It is generalized. We can have here we can have the ROC curve. So as our project is a web-based system, it is made up of using front end and back end, and is locally hosted. So we can see the file output which is running at this host ID. So so this is the page of the project. Uh, so to start detection, we can have a detector at this second page. So we can this is the order ID and the complaint is option. So we can simply keep it as 1, 2, 3, and the complaint is item damaged. We can drop the file here. So let us take some AI generated image, which is this is an AI generated image. This is the name. It's an AI image. So we can clearly have that this image is detected as a fake. So for another example, we can have a real image. So this is the real image that we took from our camera. So it clearly shows that this image is real. And that's all. Thank you.